Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. As I had mentioned in the last module, when I finished the day's work, I had mentioned that I'm going to slightly change the topic because now number of videos on chart work and day's work has been quite a lot in the series, and I thought that I'll just deviate a little bit so that it'll be interesting for me and for you as well. So I'm switching over to a new topic today, and this topic is also used quite a lot. And if you had guessed it from last time, I think I had mentioned that I might go into radar plotting. Now, why radar plotting is so much used? If you try to realize, I'm going to show you why. Look at the title itself. See, you have a course called Radar Observers course and the simulator Radar Observer Simulator course, ROSC. Previously, it was called as ROC. You have radar plotting there, and then when you come to mates phase 2, you have radar plotting, and then after you finish your phase 1 and phase 2, when you go for your orals and before you get your COC, mates COC, you need to do a course called RANSCO also. And please remember, before all these three, your radar observers course or kind of radar plotting is there in your BSc Nautical Science also. So basically 4 times you are doing this course or this process. And let me be very honest, the way I've seen majority of the people, let me say in a batch, 60 to 70% of the people, after doing in BSc, when they come for ROC course, they have forgotten the concepts. After finishing ROC, when they come to phase 2, they have forgotten the concepts. And after phase 2, when you go for RANSCO course, again, people have doubt. Okay. And this radar plotting, if you honestly ask me, is something which is used almost every day in your bridge. The only thing is you are not doing it, but your ARPA is doing it. So because of this automatic radar plotting, we as a navigator try to forget the basics and the concepts because we just become only users. And majority of the navigators, please remember, they are not able to figure out what the display is showing, what it means when I change different modes and more orientation and all, what it should give me. You should be one step ahead actually. But the problem is we take time, we get a little bit complacent because of this automatic system. So anyway, radar plotting is still there, and I feel it should be there because the manual method should always be there to cover up in case of any failures. So you should be able to do it, a quick one. So based on that, I'm trying to just make a couple of sessions on this plotting. I will give you only basics. I will not go into problems. So at least a beginner, doesn't matter if he's in BSc or your ROC course or phase 2, you'll at least know how to do the basic plotting. Okay. The subject is quite vast because if you honestly see, there are around 5 chapters when you go for the books, and each one keeps going with hierarchy. But I'm going to give you only the basics. So let us start off on the basics. Today, I'm not going to directly jump into the problems. Today, I'm going to give you a brief. All of you should know this before you start doing the problem. So that is what I'm going to do. Okay. Your targets can be moving or fixed, but I'm going to give you only moving targets. The display orientation I'm going to use when I'm doing manual plotting is going to be north up. The motion mode I'm going to give you while doing plotting is going to be relative motion. The stabilization, what we are going to do is going to be C stabilization. Then when you look at this vector trail modes, you will come across both the true and relative, but relative is more often used, and the use of relative vector is more in your radar plotting. You will realize that when you try to understand the system. Okay. And the course of ROC and phase 2 syllabus, they stipulate that I can give you maximum of 3 targets at the same time, and we'll work on relative motion mode. So whatever I gave you in the previous slide, that is what I'm going to use. So before I jump into the problems, as I said, today's session is going to be only basics. That means try to understand what we are supposed to do, and then from next session onwards, we'll start solving problems. Or I'll give you how to solve a problem. Okay. Let us look at the instruments. The most common instrument which is kind of recommended is a roller scale. This is a roller scale. Different size comes. I suggest please go for a feet 1 feet. You can use parallel ruler, but I do not recommend this because normally you will see the table you use for radar plotting is not as big as a chart table. So I don't recommend. Then you need a brass compass, approximately 10 inches. Little bit less is okay, but not the small one. You should be able to put the pencil within this. This is the most common used, so you can buy this. Or I can go for a set square. You will see set square come as 2 pieces. One is an isosceles triangle and one is a right angle triangle. If you honestly ask me, this is the most recommended. I always prefer this instrument rather than your parallel ruler and the roller scale. The same thing is for chart work also. If you remember, I always recommend set squares. They are much more accurate with less amount of errors. It's very easy to use. These two also should be approximately a feet. Don't go for the small one. Okay. This is the one of the types of plotting sheets, but I consider this very user friendly. Normally an A3 sized paper is good. Okay. You need to have a 2B pencil, just like your chart work. Your 2B pencil can be an extra dark. Some companies call it extra dark. You need a good quality eraser. And then please keep your ordinary geometry box. Why? Because your small compass will be useful in measurements where the distance are very small. Your big brass compass may not be able to help you on that. So please, these are the instruments you need for you to start the problems. Okay. As I said earlier, we'll be looking at north-up orientation and then relative motion mode, and then C stabilization and relative vector. But let us look at it. This is north-up mode. So what is north-up mode? Your north-up mode normally on the radar shows objects exactly as your chart does. Your chart is always a north-up display. Okay. So where my 12 o'clock position is always 000 degrees true. Okay. So obviously I've marked the remaining cardinal marks. Let us assume that I'm on a course of 320, just as a, so if my vessel is heading 320, this is the 320 4.5 line. How do you measure this? You always go or start from the true north in a clockwise direction, and then you will get a heading called 320. This we have seen already in chart work, so just a recap. Okay. Let us look at a couple of bearings. Why? Because the whole radar plotting is, we're going to talk about targets and bearings, bearings and ranges. So bearings is important. Let us look at just as a simple lighthouse. Let me look at a lighthouse. So when you want to measure a bearing, you should always join your vessel and the lighthouse, then start from the true north, go in a clockwise direction and see what is that angle. Similarly, I'm going to give you one more lighthouse. Again, please join the vessel and the lighthouse. Draw a clockwise motion from the true north and measure it. So this is how you measure, and this is nothing new. We have already seen this, how to do it. Okay. Your north up is also called a gyro stabilized display because for you to give this display, I need a gyro. Okay. And gyro should be as close to the true readings. Now, I'm going to show you a little bit more on this relative motion and north up. We have already seen what is north up in the previous slide. Now let us look what is relative motion. Okay. The word relative motion is very similar to something what we did in your wind triangle. If you go to the wind triangle, there also, please remember, we had something called relative, which is called your apparent wind, which is a relative. Okay, something similar to this. So what does it mean? It means that my own ship will be always locked at the center and it will never move. So this is what is my position always in the full plotting of relative motion. Doesn't matter what heading your vessel is, this is only an example. This was very similar to your wind triangle. You are always at the center. You will not move. You will stay at the center. Okay. So when you don't move, whatever you get is relative. Whatever is you get is relative. Now in relative mode, all the targets will be shown as blips. Blips are marks. Okay, and the blip what you get as a echo. So blip is an echo, and they will be plotted by two things. That means I need a range and a bearing of those blips at different times and different time intervals. So I'm going to show you a small example. Let us say I had one blip at 080 bearing. Let us assume it was somewhere around, say 9 miles or something at 8 o'clock. Okay. Then after some time at a different interval, I'll get one more blip. I'll plot that also, again with the range and bearing, and I'll mark it. So similarly, I call this target X because I told you I can give you maximum 3 targets. I'm going to show you 3. So this is the first set of blips. I can have a second target, which can also give me 2 blips. I can have a third target, and that also can give me 2 blips. So I can get more blips also, but 2 is enough depending on the time interval. Okay, this is how your relative motion north-up display is going to look like when you start plotting. All these blips are plotted with range and bearing. Okay, and your vessel will never move out of the center. Now, what is your normal next step after this? You should remember in relative motion, just like your apparent wind, the word apparent wind in my wind triangle, please remember, was a resultant of your motion and the true wind motion. That is what is your apparent. So similarly here, I'm going to get a resultant vector. So what is a resultant vector? Resultant vector is neither your course and speed nor the target's course and speed, but it is a resultant vector. That means I'm going to form a triangle. Later on, I'll tell you. So one of the vector is the resultant vector. Okay. So how do I get that resultant vector? This resultant vector is also called as RML, or relative motion line. From now onwards, I will not write the full thing. I will write RML. How do you get it? All you have to do is join the first and the second blip of each target. So I've joined the first and second blip here, target X, target Y, and target Z. I've got it. Okay. As I told you, your RML is neither your own course and speed nor the target course and speed, but it is a resultant. So this resultant is always represented by 2 arrows here, here, and here. Okay. So this is the gist of whatever we are going to do when I give you an example and try to solve and tell you how to go about the full question. I will stop here in terms of your plotting. Before I wind up, I'm just quickly going to brief you about this plotting sheet, which I told you, A3 plotting sheet. This is one of the types. You can get multiple types in market, but this one is quite user friendly. So let us quickly look what do you have on the data on the outer of this dial. The dial is a circle. So please look at this. This is a quick calculation table. It's very quick. If somebody gives me a speed and somebody gives me a time interval, I can quickly calculate how much distance that vessel can do. So that is what it is. I'll brief you later on when I start doing an example. Besides this, one more important thing is a scale. You look at the right hand bottom. I'm marking a scale with green color. That scale is 0 to 12 nautical miles. That is what I should do. Then I have second scale, which is only 0 to 6. Then I have a third scale, again 0 to 12. Then I have a fourth scale, 0 to 6. I call this scale 1, 2, 3, 4. You can call it whatever you want. but I do call this whenever I take the class, because the principle is please always use the largest scale possible. Okay. So that's the end of this first module, where it was just only introduction and briefing. Uh, I will come back soon. Then I'll show you how to solve the problem, then how to report. So that is what I'm going to do. Till then, keep watching Jal Prayag. And Vanakkam, Namaste, Namaskar. Before I catch you with the next episode.